Hi there everyone. I was fortunate enough to be able to attend CES and meet up with ORQA at their booth to see the new products and technologies that they're launching. Now you may be aware that they're launching a new FPV goggle, a new radio transmitter, and also a new FPV simulator. But I think more interesting and exciting than any of those is their new digital video system. Is it time for DJI and HD0 to move over? ORQA's doing something quite different with their system, and I'm excited to talk about it and share it with you. So let's get into it. I was really excited to see ORQA preview a number of new products this year at CES. So let's go through them one by one and see what they brought us. Let's start with their new FPV controller, FPV Control. Retails for about $90 and it's a gamepad style radio. It's a relatively inexpensive radio, but the key feature is that it has Ghost built into it. And ORQA appears to be working very closely with Tony at Immersion RC. And in fact, I learned that ORQA are OEM manufacturing electronics for Immersion RC at the moment in Europe and helping them get around some of the difficulties with manufacturing in China. Now we should note that it may be possible in the future to flash the Ghost module that is in this radio with Express LRS as well, but that's not guaranteed at the moment. ORQA also previewed their new simulator. Let me know in the comments if you want a full review of that. I didn't get a chance to play with it very much at CES, but I am excited to learn a little bit more about it. ORQA also launched the V2 goggles. These retail for $549 and they have a very similar form factor and screen to the ORQA V1s, with support for analog modules like rapid fire. They've updated the electronic design with these goggles, and that has enabled them to reduce the power consumption and heat output, and has removed the need for the two cooling fans that were on the top of the V1 goggles. In addition to IPD adjustment, they've also added in an inbuilt focus adjustment, in line with goggles like the Sky O4X and the HD02, as well as implementing a small defogging fan that has both a manual control and, interestingly, an automatic control that turns the fan on periodically to keep the goggles clear without drying out your eyes. I had a chance to look at their OSD, and I can say without a doubt that, to my mind, it's the best OSD and menu setup on any goggle that I've ever tried. It's very, very clear, it's detailed, the graphics look fantastic, and that's definitely worth a look if you're interested in configuring a lot of the settings through the goggles. But one of the most interesting aspects of this new V2 goggle is the new proprietary connector on the top of it for digital video receivers. Now, we know that ORQA have their own digital video link, and I'm going to be talking a bit about that later in the video, but they also mentioned support for HD0. So it may be the case that ORQA or HD0 are going to be coming out with a digital video receiver that also uses this proprietary interface. And we can probably expect that a lot of the configuration will be able to be done through ORQA's goggle menus rather than necessarily buttons on the video receiver itself. So I'm hoping that's going to lead to a more integrated experience. But let's talk about what I think is the most interesting and exciting piece of technology on display in ORQA's booth, and that's their digital VTXs. ORQA were previewing 3 new digital VTXs that all use their proprietary digital link at CES. Only one of them really designed for FPV as we understand it, and 2 others for commercial uses of FPV. I was able to talk at length about this new digital link with Tony Cake from Immersion RC and some of the ORQA engineers at the CES booth. And ORQA's digital link is very much unlike DJI and HD0's link, because it's built using a custom-written software encoder running on a general-purpose microcontroller and integrated GPU. No details were provided on the chipset that's being used, but we can probably assume it's an ARM SoC by someone like Rockchip with a powerful CPU and integrated GPU, and also hardware acceleration for video encoding. This is critical because they are not using an ASIC for their video encoding. And that does potentially give them more flexibility in the configuration of their link, but with some challenges in terms of performance. ORQA did also mention planning a large investment into an ASIC-based solution in the future as well. So we can assume that that is at least on their roadmap, or it's something that they're thinking about. How does this compare with DJI and HD0? Well, both DJI and HD0 use hardware video encoders built on proprietary chips, ASICs. DJI have the P1 chipset, as you can see there in that image on the left-hand side, and HD0 have the Divimath 5680, the DM5680 chip, which is the chip that does their video encoding. In comparison, ORQA are using a proprietary software encoder that's running on commercially available hardware. Now, they were quick to point out that this encoder has been created from scratch, coded from the ground up to be as fast as possible and uses, all the latest encoding technologies. But fundamentally, it's still a software encoder running on a general purpose microcontroller. So what are the advantages of using a software-based solution like this? Well, it's extremely flexible and configurable for different purposes. You can trade off between latency, quality, and data rate for different applications. And of course, it can benefit from whatever general purpose hardware is available. It's likely that the code can be ported onto different solutions. And as general purpose hardware improves, as microprocessors, integrated GPUs, and hardware accelerated video encoders get faster in the future, then it's possible that ORQA can take advantage of this to improve their solution. But a software-based solution does have some disadvantages and limitations. It's very hard for me to imagine that the raw performance of any software-based solution can match the performance of a proprietary ASIC. There is going to be some trade-off between image quality, latency, bitrate, frame rate, all of these things. It seems very, very difficult to imagine that the raw performance of a software-based solution is ever going to match a hardware-based solution. Also, from an IP perspective, if ORQA can do this, then other people should be able to. They should be able to match the performance of ORQA's solution when they're using the same hardware, because although it's proprietary software, and although a lot of time has been invested in it, someone with equivalent knowledge and experience should be able to replicate the performance, particularly as we learn more about exactly how ORQA's solution works. A project like OpenHD is likely to be able to capitalize on whatever we learn about ORQA's solution and should be able to approach similar performance when running on the same hardware. Let's talk a bit about performance. So based on what I was told by ORQA, the link is very likely to be capable of 720p 60, exactly the same as SharkBite. The encoding latency is around 20 milliseconds. Now, in comparison, HD0, the encoding latency is around 1 millisecond. So you can see the difference in speed between a software-based and hardware-based solution here. The end-to-end latency is going to depend on the camera that's used, but realistically, it's likely to be pretty similar to DJI at 60 FPS. And how close they can get to DJI performance really is going to come down to how well optimized their software-based encoder is and how closely it can compete with DJI's proprietary P1 chip. Looking at the cameras now, the ORQA system is going to be compatible with all the MIPI style cameras from companies like RunCam and Foxeer. So we should expect that they'll have similar access to cameras to HD0. It doesn't look at the moment like ORQA are intending to make their own FPV cameras, although never say never on that. But it definitely looks like they will be making the system open for companies like RunCam and Foxeer and Cadix to make cameras for their system as well. Again, no frame rate or resolution was specifically mentioned, but 720p 60 is my working assumption at this stage. I don't anticipate that 720p 120 is going to be something that they target with this system. and I imagine that they'll be able to support 4:3 or 16:9 resolution. So let's look at each of the VTXs in turn now, starting with what I think is going to be the most relevant one for FPV, which is this 5.8 GHz race VTX. This is a 200 milliwatts, 5.8 GHz video transmitter, and it uses a Wi-Fi 5 SoC from Microhard as the radio. And this supports diversity transmission, and you can see there's two antennas. And I'm expecting that performance in terms of the radio link should be very equivalent to the DJI Air unit at 200 milliwatts of output power. ORQA were very keen to stress that this video transmitter is going to have a fixed latency, and it is designed for racing. And this means that breakup of the image in some way is going to be likely in low signal to noise situations. And I'm anticipating that the breakup is going to look very similar to the DJI audience mode, because in audience mode, the DJI goggles don't have retransmission, and you can see how that affects the image quality and how the signal breaks up. ORQA are going to be suffering from exactly the same situation. They're going to be having a digital link with no retransmissions, which means that their breakup is going to look very similar. And it will look very different to HD0's breakup, which, because they use joint source and channel coding, their breakup has a particular look to it that is somewhat different. The HD0 breakup looks more like analog breakup, whereas the breakup in this system is going to look more like the DJI audience mode breakup. The second VTX that they showed is a 2.4 GHz VTX designed for commercial applications. And this is a 1 watt plus video transmitter. Again, it uses a Wi-Fi 5 SoC from Microhard that supports diversity transmission. And this unit is probably too large for mini quads. I mean, it's 60 by 40 by 15 millimeters. You might consider putting it in something like a 7-inch long range quad, but not a race quad or a micro, nothing like that. I believe ORQA are intending to configure the encoder in this VTX differently from the 5.8 GHz race VTX. It's likely to have more latency. They were talking about just under 100 milliseconds, and much longer range, much better penetration, and much better image quality in low signal to noise situations. And that means that they are likely to be using retransmissions. Now, what's interesting about this being a software-based encoder rather than a hardware-based encoder is that it should be possible to use all the different encoder settings on all the different VTXs. So it may well be possible to use this larger 2.4 GHz VTX with the same encoder settings as the race VTX to get lower latency if you want to do long range, but you still want to have that low latency. That should be possible. The final VTX that they showed is a 5G cellular VTX. And this again uses a radio from Microhard, but this time it's a cellular radio. And this unit is also probably too large for mini quads. It's about 50 by 50 by 20 millimeters. And it's designed for remote telepresence beyond line of sight. Again, similar to the commercial VTX, we're talking of a latency under about 100 milliseconds. And because it's a cellular connection, the range is almost unlimited. I mean, it's wherever you have 5G connectivity. Tony Cake from Immersion RC gave the example of sitting in your house in the UK or in Europe and being able to remotely log into a drone in the Grand Canyon or at the Great Wall of China, and then being able to fly that location from the comfort of your own home using this video transmitter with acceptable latency. I mean, it's not going to be the same latency as you're going to get if you were there, but for people who can't travel to those locations and fly those locations, or people who want to go and fly locations all over the world, this is a really cool enabling technology for that. And the final thing they showed was a really cool little thing, a USB-C charger for your goggle battery. So it allows you to charge a 2S goggle battery from USB-C. This is not exactly groundbreaking, but I think it's pretty neat anyway. I hope you enjoyed that roundup of the new products and technologies that ORQA were showcasing at CES this year. If you'd like to learn more about what ORQA and Immersion RC are up to, I'm going to be organising an interview with Tony Cake from Immersion RC very, very soon on my channel. So make sure you're subscribed so you don't miss that one when it comes out. If you like the work that I do and would like to enable me to spend more time making videos like this for you, then please consider signing up for my Patreon. You can join for just a few dollars a month and it'll give you access to some special resources on my Discord server, as well as sneak peeks of the projects and new frames that I'm working on as well. I'll put a link to that down in the video description. That's all I have for now. So until next time, I wish you all very, very happy flying.